Let's get going. And, you know, I've met people over the years, and even people that I've known before, and inevitably, as soon as I meet them, you find out I'm a seismologist. The first question is, well, when's the next big one? Okay. It seems that people think that's what seismologists do, is predict the next big one. Well, indeed, most of us don't, and most of us don't even try very much. Now and then we may dabble in things that might lead to true earthquake prediction, but there's so many other fascinating topics in seismology and geophysics that we're mostly concentrating on these. And if earthquake prediction, and we'll go into what I mean by that in a moment, really comes to pass, well, very good. But fundamentally, the bottom line is we can't do it. So if you understand this slide and you've got the whole picture of tonight's lecture, you could just pick up and go home. But essentially, to have a successful earthquake prediction, it means you have to know the size of it, the location, and the time, and you have to specify that to a degree that is better than sort of the historical background. Well, and at this point, there is no scientifically valid, socially useful way to do this. So, if asked, when's the next big one, I'm not going to answer it. But to get going, just to see if you're sort of following along now, and I did have a history at a university, and so we like examinations. We're going to have a little pop quiz here, okay? But I must warn you, I am sometimes mean, and therefore we could have some trick questions. So, but let's get going. We'll do a little yes or no, true or false. The longer it has been since the last major earthquake, the nearer it is to the next. True or false? Okay, well, that's not bad. True, of course. True only in the sense that, well, the longer it's been since anything, the nearer it is to the next thing. In other words, this is a pretty meaningless statement. Time moves forward, so it's always nearer to the next thing. Yeah, I told you, it's sort of mean. Well, let's a little bit more scientific. All, at least major earthquakes, occur within 3 months of an equinox. True or false? Well, guys, smarter than average thing. Yeah, of course that's true. There are 2 equinoxes every year, and so all time is within 3 months of an equinox, right? Okay, this is just to illustrate the types of things you sometimes see in the press, which can get you to thinking. Well, let's go on now. The last one here. Because small earthquakes are more common than large ones, they are easier to predict. Remember the bottom line. True or false? False? Indeed, false. You can't predict either one. Now, indeed, small earthquakes are more common, but by the definition of a good, valid prediction, you have to do so better than what their average occurrence is, and we can't really say much about either one in a useful way. Well, let's sort of broaden the view of prediction here and go to sort of 3 different ways of anticipating a future event. I'm going to call one forecasting, the other is prediction, deterministic prediction. And then at the end of the talk, I'll touch on a topic that a seismologists call warning or early warning. That is, this is the case where an event has already started and you essentially predict the consequences of that event after it started. So you're not predicting the event, but you're warning of some consequences coming shortly. But to contrast forecasting, which typically is purely statistical, and indeed you can't be wrong. You know, it's 60% chance of rain. Well, you're right if it rains, and you're right if it doesn't rain, because the probability is always greater. Unless you say it's 100% chance or 0% chance, you can't be wrong with a forecast. But a deterministic prediction is for a specific event. So, again, forecast, it'll rain so many days in Portland next year. That's based on history, and often in weather we call this climate. We don't call this weather prediction, we call it the average climate. Forecasting then is when you say the percent chance of an event occurring. And it's usually based on something about the past. There are so many earthquakes of magnitude 3 or greater will occur next year in the Pacific Northwest. This is a forecast for earthquakes. Now, prediction, on the other hand, is for a specific event. And there are a couple of different ways you can look at it. Repeatable observations are one that have been sort of claimed to be good predictions. And obviously the case that, the obvious, the sun is going to come up tomorrow, because it's been coming up every day for the last umpteen years. You don't even need to understand the physics of that. Of course, the sun doesn't come up. We sit on a rotating planet, so it appears to come up. But even if you don't understand the physics, you're pretty good about saying that because it's something that seems to keep on going on over and over. A few years ago, there was a case where there was an earthquake at St. Helens every minute, and it went on for months. Well, you could predict that there was going to be an earthquake during the next minute, and inevitably there was. So a repeatable type of an event. But all this is really not that interesting or really very useful. The really interesting problem is that unusual event, the one that doesn't occur in a regular pattern, that you can anticipate because of some precursory phenomenon. So, you put a pot of water on the stove, turn on the stove. When you see bubbles forming in the bottom, you predict that it will boil. Steam will come off of it. Even if you don't understand the physics necessarily, if you've done this a few times, this is a deterministic type of process. At a volcano, you see increasing numbers and sizes of earthquakes suddenly appear and get larger. Well, you can predict that the volcano will erupt soon. And indeed, that is fundamentally the way that works. There's some subtleties, but that's basically it. Now, this confusion between prediction and forecasting occurs in the press all the time. Here's an example of a few months ago. A local newspaper claimed that an Oregon State University professor predicted the Haiti earthquake. Now, I don't know if Bob Yates is in the audience, but if he were, I'm sure he's very embarrassed by this. He didn't predict the earthquake. Actually, the press release from the university said that he forecast the tremendous destruction that that quake would cause. And that was actually based on the fact that he understood something about the geology of the area and that earthquakes were likely sometime, not specifically when, and the construction there is very poor. And so the forecast really was a forecast of disaster, not of an earthquake. And indeed, there's a group at Columbia University that studies this on a worldwide basis and sort of uses the combination of where they know earthquakes occur and where there are vulnerable populations to do earthquake disaster forecasts. And this map shows sort of a version of that. So let's keep in mind these differences. And the interesting thing, of course, is the prediction as far as the curiosity. But I'll get back to it at the end. The really socially useful is, in fact, the forecasting.